I'm going to briefly demonstrate how to use an interactive simulation for the Hunter-Nash method for liquid-liquid extraction. And the simulation uses a step-by-step procedure to help you understand essentially how the mass balances can be located with points on a ternary phase diagram. The simulation is located here, and on the LearnChemE site there are screencasts that describe in much more detail the Hunter-Nash method, and here I'll just show you briefly how they used the simulation, but not talk about all the details of the Hunter-Nash method. So here's a snapshot of the simulation showing one of the steps, the mixing point determination, and we can go step by step through, and including counting the stages required to give certain separation. We have a choice of 3 possible feed mole fractions, and pure solvent enters the system, and then we fix this raffinate phase composition, the final one we're aiming for, and we also fix the feed flow rate and the solvent flow rate. The feed flow rate is 1,000 kilograms per hour, and the solvent flow rate is 1,500 kilograms per hour. So let's look at the interactive simulation. So what the Hunter-Nash method demonstrates is essentially a visual way, graphical way of representing the mass balances. So the mass balances are shown here in the details. And if we pick, say, one of the feed compositions, now you notice we can also show the solvent or the raffinate compositions. For the feed compositions, if we go to the next step, which is determine the mixing point, again, just from mass balances, this is the composition. If we were to mix the solvent and the feed together with their relative flow rates, this is the composition we would end up with. We can then determine the first extract composition using that mixing point and the raffinate composition that we're aiming for. So this is just overall mass balance. Then we can determine something called an operating point, again using mass balances and showing equation up here. And then we can proceed to count off the stages, the number of equilibrium stages, where if I move the slider, R1, E1 are phases in equilibrium. And then if I step through the next step, again, tie lines indicate phase equilibrium, and this diagram explains what R2 and E2 correspond to, right? So they're leaving stage 2, and E2 and R2 are in equilibrium, and we can step along until we determine the number of stages required for the desired separation. So liquid-liquid extraction allows us to remove a solute from one phase and transfer it to another phase. And this Hunter-Nash method is a graphical way of determining how many stages we need for desired separation.